All right, so we have two things left to look at in this half of this chapter, especially before we get to your test next week. We did radical expressions yesterday, so you were not with us yesterday, were you? Okay, so if you have your list of square roots or your perfect squares, we're going to need them today. Operations that we're going to look at: how do I add? How do I subtract? How do I multiply radical expressions? All right. Part of it you're going to see is very similar, very familiar to the idea of like a like term. And then we'll kind of branch off from there a little bit. So, how do we add and subtract when we have what are called like radicands? We'll talk about what that means. How do we do it when we have unlike ones? How do we multiply them together? Before we get too far into it, though, based off of what we did yesterday, can you give me an answer to either one of those? So, take a second and think, is 54 a perfect square? Hopefully, you would say no. Is there a perfect square inside of 54? Hopefully, you'll say yes.
Yes.
And then the next question becomes, well, what is it? What is the biggest perfect square that goes into 54? If you think you have it, split it into its two factors. Take the square root of the perfect square and leave the other factor under the radical. And the same could be thought of for the second one as well. What am I splitting that into? If you're uncertain, remember we talked about taking a number like 54, cut it in half. That'll tell you the halfway point. It would tell you what perfect squares are possible. Half of 54 is what? 27. So you could only have perfect squares that are less than 27 as a possibility. That only have a whole lot of options. Yes, ma'am. 25 would be the first one you could check. Can I do 25 times something to get 54? No. What's the next one smaller than 25? 16. Does 16 go into 54? Really? 16 times what would get you to 54? That's a hard no. What's the next one smaller than 16? 9. Does 9 go into 54? The answer is yes. So, Faith, 9 times what? 9 times 6. Okay. Yes, sir. What's the other option?
I used 14 and 4.
Okay. 14 times 4? It's not 54.
Oh. Never mind, I didn't use that one.
Okay. So, which one of those two numbers is a perfect square? 9 square root of 9, Faith, is 3. So, my final answer should be 3 square root of 6. Okay. Now, as I look at the second one, is 60 a perfect square? Can you find a perfect square inside of 60? Hopefully, the answer there is yes. Emily? 4 and 15. Very good. Is b to the third a perfect square? And the answer is no, because of what? Good. The exponent is currently an odd. It's not an even. Can I make it an even? Emily? Good. So b to the second times b to the first. You have 4 factors underneath your radical. How many of those 4 are perfect squares, Hunter? 2. Which 2? Good. So the 4 is going to be square rooted. The b squared is going to be square rooted. I know at this point the 15 and the b are remaining. Han, what is the square root of 4? And the square root of b squared? There you go. Okay. All right. So we'll need this idea continuing on today when we try to get into the idea of addition and subtraction. All right. So our two goals or objectives for today: can I add and subtract radical expressions, and then can I multiply them? All right. So that's what we're going to try to get done. So here's number one. As you take a look at that, initially, you might look at that like, I don't really know maybe what to do here. It looks like it. I'd agree with you. Kelsey, could you answer this question? Could you do that? If you wanted to. Well, how about you want to real quick and tell me what your answer to that is? Three x. Right? Okay. How do you get an answer of 3x to that? What did you do, Faith?
You add 6 and 2 and 8 and then minus 1.
Good. Why am I able to put those three things together? Because they are
They all have the same root.
good. So what do you call those? Like terms, right? Well, this expression up here has what we call like radicals. It has a square root of 5, another square root of 5, and then thirdly, another square root of 5. Meaning, I can put this expression together the exact same way I put this expression together. Anybody want to take a guess on what my answer to this top one would be? It would be 3 square root of 5.
How'd you do that in your head? Or did you just know the answer?
Because I know how to add 6 plus 2 and take away 5.
Oh.
But why do you
Why do I keep the square root of 5?
Yeah.
The exact same reason that I kept the x when you added these three together. I was able to put 6x, 2x, and 5x together because they all had the same variable. I don't know what x is worth, but I know that if it's the same in all three, I can put all three of them together. You agree with that statement? Well, here, each one of these has the exact same square root of 5 attached to it. So because they all look the same, I can put their coefficients together. It's no different. We would call this bottom one like terms. We'd call this top one like radicals. It's literally that straightforward. So if you look at this one here, can you add those together? All of them? Some of them? Okay. Give me something you can put together. Okay. So these two right here match. So I can put them together. How much do I get when I have 8 radical 11 minus 4 radical 11? I have,
4 radical 11.
okay, so this piece here would be 4 radical 11. What about the first one and the last one? Can they go together? Megan, what do you think? Yes? So if they can, how much do I get when I put those two together? I get 1 radical 2, right? A 7 and a minus 6 would be 1 radical 2. You have two choices. You can either put it here, so you could put the 1 radical 2 there, or you could put it up there. And obviously at that point, then you'd need to put the plus in between. Okay? You could write the 1 in front of here if you want. You would not see it written that way. So if you want to write it there, that's fine. Just understand that if you're looking for it, you wouldn't find it. Okay? That'd be like if you had 1x, you wouldn't typically see 1x, you would just see the x by itself. Okay? You with me so far? Okay. Don't even write this one down. Tell me, which one of those 4 is the correct answer? If you think it's A, hold up 1 finger. If you think it's B, hold up 2 fingers. If you think it's C, hold up 3. If you think it's D, hold up 4. Okay? So when you think you know what your answer is, just simply 1, 2, 3, or 4. We'll let that be A, B, C, or D.
wait, how many fingers?
A is 1, B is 2. Good. So the overwhelming result we see there is choice D, right? They're all radical 13s. So 3 plus 4 is 7, and 7 minus 2 is 5. All right? Is that terrible? No? So now you got to get your first curveball. Ready? All right, here we go. Get your wine on. Can I put those three together? Why not? What?
You can find in the middle has a
Oh, dang. All right. So first of all, they don't match in their current state, right? Their radicals are all different, right? But let's look at 27, for example. Do you see something inside of 27 that maybe I could extract out? Is there a perfect square inside of 27? Cody? Times? Beautiful. So I'm going to rewrite this one for a second to say 6 times the square root of 9 times 3. Okay. What about this middle term? Can somebody find me a perfect square inside of 12? Kels? 4 and 3. So I'm going to rewrite this middle term to say 8 times the square root of 4 times 3. How's about the last one? Can you find me a perfect square inside of 75? Huh. 25 and 3. Very good. So I get 2 times the square root of 25 times 3. Okay. Now, here's something we have not seen yet. If I take the square root of each of these perfect squares, they are going to come outside the square root. But in each one of these situations, they're going to join a number that's already there. How will I join the square root of 9, which is 3? When I join the 3 with this 6, how will I join them together? Will I add them together? Will I subtract them together? Will I multiply them? Will I divide them? It's got to be one of those choices. The natural reaction feels like to do what? To add them together, right? But let me ask you this. When you have a number sitting next to something else, what operation is being implied? Multiplication. So when I pull it out to join it, I'm going to multiply it. Okay. So when I take the square root of this 9 here and I join it with the 6, I'm really doing 6 times 3, which is, no, you're good, which is 18. So my first expression is going to say 18 radical 3. What's my middle part going to say? Kelsey? Good. 16 radical 3. What's my last one going to say? Charlotte? 10 radical 3. Okay. I'm going to ask you the same question I asked you just a minute ago. Can I add any of these three together? A minute ago, we said no, right? But actually, the answer was yes. So if I can, best fancy bracket you've ever seen. There it is. Okay. That is actually a pretty nice one. All right. What is my full answer to that when I put it all together? Kelsey, what do you got? There you go. Okay. So at face value, I might look at a radical and say they can't go together because they don't have the same value under the square root. Okay. But if they have a perfect square inside of them and I take that out, I may find that it works. Now, what if the first one was 18 radical 3 and the next one said 16 radical 5 and the last one stayed 10 radical 3? Could you put them together then? If this number here, if that was a 5 instead of a 3, could you put those together? Emily? Good. You could put the outside ones together, but not the middle one. Okay. If they were all different, could you put any of them together? No? What would you do? If this one was radical 3 and this one was radical 5 and that next one was radical 6, they were all different. What would you do? Well, they don't have one. 3 is a prime number, 5 is a prime number, 6 isn't prime, but no perfect square in it. So what would I do? Well, I wouldn't be able to combine them together. I guess I'd just like circle it or something, like indicate that I understand that I'm done, like that I can't put those together. All right. Try this one. See, well, let's get it on the same screen there. See if your answer matches one of those by the time you're done. What you looking at me like that for?
I totally would. I got lost. I was asking Cody, like, how you do this?
I didn't ask Cody anything. I'm just happy he's here. 3 in a row.
How'd you go from this or this to this?
Because the square root of 9
It's 3.
is 3. This 3 is there. When you take the square root of 9, you get 3. So when you join 3 with the 6,
6 times 3.
6 times 3 is 18.
So that's great. Okay.
Yep. That makes sense?
Yes.
I'm liking the new haircut.
I told him that.
Did you?
He gave me attitude. I did.
Oh, all right. It's aggressive, but all right.
I mean, today is hump day.
I don't see how that plays in, but okay. I mean, okay. I don't even know what to say to that. $245. That's big. Oh, whose calculator is this? Whose notebook is this? Aiden. All right, Aiden. Let's leave that for you. We'll get it later. What's that? So in each one of those, you're looking for the perfect square, if you can find one. Okay, in that first one, I located 49. So 49 times 5 is equal to 245.
28 a perfect
Good job.
square.
Is 28? Is it on your list?
My list is always
I'll just tell you no. Very good. Light work.
I'm getting it.
You're good. How we doing over here? You don't know. It looked good so far. Dakota, are there batteries in that calculator? Does it turn on? The other one's dead? Toss. Thanks. What's the perfect square inside of 125? 25 times 5. And what's the perfect square inside of 80? Okay. Looking at those 3 parts of the expression right now, you going to be able to add them together when you're done? How do you know that when you look at it? Because they all got 5s in them, right? They all have a perfect square multiplied, and the other factor is a 5. Well, if I extract the perfect square out of there, the remaining piece is going to be a square root of 5. So in the first one, what's the coefficient that goes in front of that, Hunter? 42. Good. Square root of 49 is 7. 7 times 6 is 42. Almost. 42. Good. What's the middle one going to look like, Han? Good. So the coefficient is 15, radical 5. And on the end, Jess, what's the coefficient? It is not an 8. What square is 16? 16 divided by 2 is 8. You cut this in half. 4. Good. All right. 4, radical 5. Good. So because all three of them have radical 5 in them, I know I can add them together. So my right choice, hopefully, is choice A.
Yes.
Yay me. Okay. So adding and subtracting, really not a big deal as long as you locate the radical. And if the radical matches, you can add them together. If it doesn't, then you can't. Okay. So let's shift gears. What does it look like if I multiply? Any takers? Now, multiplying radicals is very similar to multiplying variables. Like the rules aren't the same. I can't do this if it's addition and subtraction. If I had 3x plus 5y, I can't do that, right? Because they're not like terms. But if I'm multiplying these two, the rules are different. I can multiply those two together. 3 times 5 is 15. X times y is literally xy. I can multiply those two together. Okay? Radical expressions can be thought of very similar to that. Just because those two can't be added together does not mean they can't be multiplied together. You want to take a shot at it, or you want me to tell you what this first one is? So your answer is 8 radical 18. Okay, right? You're like, oh, okay, I see where that's at, right? I can put together the coefficient that's in front. 2 times 4 gives me the 8, and then under the root, square root, the 3 and the 6 gives me an 18. Now, I'm not truly done here. Anybody know why? Emily? Good. There's a perfect square inside of 18. What is it? We're about to fight. 16. 16 times what would get you to 18? 9 and 2. So we should be looking at this as 8 times the radical of 9 times 2. Which really means that my final answer to this is... Connor, what do you think it is? Yep. I got a perfect square right there that's got to come out. How's it coming out?
Oh, you have to put it in the outside. So it'd be 9. Nope.
It's all right.
3.
So it's a 3, but when I join the 3 with this 8, what did I just do when I brought a number out of the square root? What operation put those together? You and I literally just talked about this. Yeah, well, you would multiply. It'd be 24. Radical 2. Okay? What does it look like here? Here's one of those things like, okay, this looks different, but based off its setup, I should know what to do here. What should I be using here? What property? I should be distributing, right? I should be multiplying those two together first. And so for a moment, that's all I should see are those two parts of that expression being multiplied together. So if I do that, what do I get? Put the coefficient together. Dean, if I multiply those coefficients, what do I get? 12. And under the radical, what do you get? 4. Now that's part 1. Now I got to go to the second part. Megan, what's the coefficient part there? 8. And the radical? 12. Am I done? No. Is there something in there that I can do? Emily, what do you think? Okay. So in the second half, I could rewrite the square root of 12 to be a 4 and a 3. What do you want to do with the first part? It already has a radical 4. We'll leave it. Okay, why do you want me to leave it? Okay, so now what? Am I done? No, what can I do now? Okay. Okay. In this one down here? Okay, so the perfect square in there is the 4. When I bring the 4 out, what do I get? Okay, so I'm going to get 16 radical 3. What do I get to the first part? Square root of 4 is 2, and there's already a 12 there, so you get 24. Now, do I have a radical anymore? Why not? I square rooted the 4. Was there anything else there? So there would be no reason for it to be there. So I have 24 plus 16 radical 3. What do I do with those two? Can I add them together? Why not? Okay. They're not like terms anymore, like radicals. One of them has a square root of 3, the other one doesn't have anything. So that is as far as I can go. Okay? Last one and we're done. What do you think? Faye said, yes, please. All right. We'll let that one go. Here's the last one. Oh, sweet. No, that's not really words. Come on now. So I'll find the area of a rectangle. How you find area? Length times width. I know what the length is. I know what the width is. But each of these, hey now, come on. Oh, geez. How am I going to get to that? Come down here for a minute. Come here. Huh? I am struggling. I got to multiply those two together. Oof. What process, let's call it a process, that you hopefully remember will put a binomial, 2 items, multiplied by another binomial, 2 items. You just said you didn't remember what it was called. No, it is FOIL. Very good, right? And FOIL stands for what? First, outer, inner, last. Good. So really what I'm doing is I'm double distributing, right? I'm going to distribute here twice. Okay. So we're going to start it and you're going to see if you can finish it. Okay. So what is the F in FOIL here? It is going to be the first in each of them. If I multiply those two together, coefficients and then radicals, I get a statement that says 20 radical 18. That's first. Okay. O, outsides. Okay. 4 times 7, 28. Radical 30. After the O, we go to the I, which would be inner, the inside ones. Now you be careful, there's a negative in that. So negative 2 and 5, that's negative 10. And then square root of 10 times square root of 3 be square root of 30. And in this process, the only thing left is last. You see me struggle there to pick a color. I couldn't figure out which ones I had used and hadn't used. Struggles. Negative 2 times 7 be negative 14. Square root of 10 times square root of 5, square root of 50. Okay? So 2 questions. 1, if there's anything that that's not a question. Is there anything that match?
Yes.
Okay? So what can I do with things that match? Put them together. And then the second question would be, are there perfect squares in any of these square roots? If there are, you got to find them. So that's 2 things you should be looking for. What's that?
I was going to answer your question.
Oh, I'm sorry.
Does those headphones hear us?
Did they hear you?
Yeah, they hear us.
If you're close enough, they do.
Say hi.
This would be a personal shout out. Go for it.
Who am I shouting out? Hey, good luck on your test. I mean, you already took it, but have fun.
That was bizarro.
I'm stuck.
You're stuck? When you start dealing with square roots, I hope you guys are starting to realize you keep seeing the same numbers show up again and again. Like, how many times have we seen radical 18? Enough, hopefully, for you to realize that what perfect square is in there? A 9. That's not yours. Please don't balance it like that. When it drops, you're not going to care, but I'm going to care.
Right, drop.
I know. Does 50 have a perfect square in it?
Yeah.
Yeah. What goes into 50? 25. So now 30? No. What things get you to 30? 6 and 5. Neither one of those are perfect squares. What else? 10 and 3. Not perfect squares. That actually works out in my favor because these two are like terms. I'd like to put those two together without messing it up, to be honest with you. I try not to. So you guys said we were going to split that into a 9 and a 2. In the middle, you have 18 radical 30. You also said that I was going to split 50 into 25 and 2. Looking at my first and last term, looking at the first and last term, you going to be able to put them together? Are you going to be able to put the first one and the last one together? Yeah, because they're both going to have what in them? Radical 2. So, you don't have to do this right here, but I think it's important that you're able to identify what it is that's about to come out. If you go back through any square root I've ever written, I do it the exact same way every time. Perfect square first and the other factor second, no matter what it is. Even if you tell it to me in the other direction, I always write the perfect square first. I'm a little weird. It's all good. I know it. I accept it, and I love myself, okay? So, but that way I know what it's going to look like. Like that's just for me. So when I bring this 9, square root of 9, out to join the 20, what do you get for a new coefficient? You get 60. So that would be 60 radical 2. I don't need to do anything with the 18 radical 30. Not yet. On the end, what do I get there? You're bringing the square root of 25 out. What's it come out as? Comes out as it comes out as a 5, but when I do 5 times 14, yes, I get negative 70 radical 2. Am I done? What's up? Good. For a grand total of -10. Good. So first one and last one are like radicals. So let's bring those together. That's -10 radical 2. What do you do with the 18 radical 30? You add it on. Add it to the beginning, add it to the end, whatever makes your little heart happy. Okay? It doesn't matter which side you write it on. It's the same either way. That's your final. Well, can you put these two together? How? You already told me there was no perfect square inside of 30. You can't put that mask back up and act like nobody heard that. Okay? Those two don't match, so you cannot put those two together. All right? Now, that is a total of 7 questions. Okay? 7 questions. Remember, columns go which direction? Columns go up and down. So you're picking, that's 4 questions. And then there are 3 at the end. All right? Tomorrow we'll look at radical equations, and then it's all hands on deck for next Thursday. Okay?